I just want you to watch. One crank, I'm going to show it as this. All right, one cycle. And I'm going to say the amount of work done was 1.6 joules. So one of these is how much energy?
1.6 joules.
Okay, now I'm going to do this. How much work?
3.2.
Okay. So, 2 cranks. And 3.2 joules. Now, I'm going to do this. Oh, sorry, let's try again. How many was that?
2. No.
3. Okay, it was 3. And I'm going to say this was 3 in 1 long second. So now I have 3 cranks, 1 second. So let's see, like that.
It's something over.
So this size from here to here is 1 second. How much work did I do?
4.8.
Wow, all right. Why 4.8?
Because it's just, yeah,
Why 4.8?
you add on this 1.6.
You added on 1.6, why?
Because that's how much one crank is worth.
Okay, so for every cycle, it's 1.6 joules.
Per second. They're not
Now, so I'm going to call this work. We now know this as a quantity called work, right? So the second piece of information I'm going to add is this per second piece. So what was the amount of energy per second?
3 cranks,
Yes, in this picture here.
4.8.
Okay, why was it 4.8 joules per second?
It was over 1 second.
Because it happened over 1 second. Awesome. So we're going to call that power. So now we have another power piece. We could also add something else in. How many cycles did I have in 1 second?
3.
Brett says 3. Does everyone else agree?
Yeah.
Okay, 3 cycles, 1 second.
3.
Yes.
Wait, so we shouldn't be writing it?
Nope, not right now. You can write it down at the end. I just want you to actually be able to catch what's happening.
Okay.
3 cycles per 1 second. All right, so let me assign a symbol for this. We're going to call that symbol frequency. Here it is. Now I'm going to start a new little section here, and we're going to actually do a problem that you might have seen on the investigation. Now I have, let's see if I get this right, 5 cranks in 10 seconds. So if this is the second, so if this amount here, I'll put this is going to be really hard. Let's see. I'm going to represent the time interval with that piece. Now within here, how many cycles will I put? If that's 10 seconds.
5.
Okay. So they're going to look really big, right? So imagine it like spreading out a bit. All right, that's 5. What was the work done? So how much energy was transferred during that time? Bobby,
8 joules.
why 8 joules?
Because 5 cranks, and that's 5 times 1.6, which is 8.
Okay, so 8.0 joules. So we did 8.0 joules of work because there were 5 cycles, and there's 1.6 joules for every cycle. What was the frequency? I'm going to show it to you in a different way too. So it's the number of cycles per second. So how many cranks per second? Zoe?
0.5.
Why 0.5?
Because you have to divide them, so it goes over seconds, so you divide by 10.
Okay, so the number of cycles per second So 0.5. I'm going to show that in another way. It's kind of interesting. I'm going to show it like this. Yeah, it's a weird piece. What is this supposed to represent? Nina? Half of a cycle. Okay, ready for this? How much energy was there per second? It's half a cycle.
Oh, 0.8.
So you would divide
Wait.
2.6 by 3.
I heard it.
No.
It's half of a cycle.
So 0.8.
0.8.
Oh, yeah.
So 0.8 joules per second, because there's half a cycle per second. That's it. This is pretty much how to do work, how to think of power, how to think of the frequency, conceptually. That's it. So did we use formulas to do this? Nope.
That was a simple number.
Nope, no formulas, we just used our intuition. So the next part of this is I'm going to ask you to do a quick little practice sheet that I have. It's just a couple problems, and I'll take them back just to see how you did. Thanks.